Alright folks, I want to give you a demo on how to use an auto-ranging multimeter like this Zotac VC921 or Victor VC921 here. These are somewhat easier to use than the manual ranging ones, but they go slower. They actually use usually the same or similar ranges that the manual ones have. They are just internally doing some tests to check to figure out what range their reading should be in, and then adjusting their calculations based on that. So they run a little bit slower, and it can take a couple of seconds for them to arrive at the value. Most of our activity on the multimeter is going to be on this central dial here, which is going to select our different functions. So if we look at that, the very first one is a squiggly line with a V, or a sine curve with a V. That's for reading AC voltage, like what comes out of a house wall outlet. We're not going to be using AC really much in this course at all. While you can measure AC voltage with a multimeter like this, you can also kill yourself with AC voltage if you interact with it wrong. So we're not going to approach that subject. The next one is our DC voltage. That's the line with the 3 dashes, which we're going to use all the time in our course. Compared to AC, DC is relatively safe. And with physical computing, we're using extremely low voltage. So we're going to turn our dial to that, and we'll see the screen lights up, it turns on, and it tells us some information. It says auto, it's in auto mode. It says DC, we're in DC measuring mode, and then it has over here a little V for volts. That's the units that we're going to measure. We can pop out our leads or probes here. These pocket multimeters, the probes are attached, right? And there's two, and you have, that's it. More high-end multimeters will have 3 or 4 or more different connection points where you can connect the probes to, depending on the kind of readings that you're doing. Usually that has to do with measuring current. This meter can't measure current at all. Is that a downside? Yes. It would be nice to have a meter that measures current. There occasionally are times when you will have to do that, but you should be able to get by our class without that, and in the off chance that you really do need to measure current, you can use one of the meters in the labs that has that capability. But again, that's why this one doesn't have the adjustable points. They're just connected. To measure voltage, we place our probes onto a circuit to measure the voltage running through it. So we need something that actually is connected to some kind of power. I've got my Circuit Playground Express here, and I'm going to use that to measure voltage on. If I look at the Circuit Playground, and let me switch to a close-up view, here we go. We can see some of these pads. There's a 3.3 volt pad next to the USB jack, and then on the other side there's a ground pad. I'm going to use both of those, and then I'm going to use this V out pad down here as well for these tests. So when I place the probes, I want to put my probes directly touching these pads, and I'm going to connect the black one, which is my ground probe, to the ground pad, and then I will connect my red one to the 3.3 pad, and you'll see the meter pretty quickly goes to 3.305 volts. Okay, so that little discrepancy could be in the accuracy of the meter or in the actual power coming out of the Circuit Playground, but that's pretty good. It's a very minor miscalculation. Alright, so if I switch these leads around, I'm going to keep the black one on the ground pad, but then move the red one down to V out. I get 5 for 5 volts. So with the Circuit Playground operates on 3.3 volts, right? So that's why it has a 3.3 volt pad. So if we use any sensors or anything with this, we want to make sure we're using 3.3 volts, but it still gives us access to the raw voltage that it's receiving, and that could be from the battery pack over here or from the USB port. And USB, the spec for USB is 5 volts. So when we have the USB connected, and we measure the V out, we're going to get 5 volts. If we have the battery pack, these LiPo batteries are usually 3.7 volts, so we would get 3.7 usually if we were going to measure with the battery connected. So that's how we measure voltage. If we do it backwards, right? If I have the red one on my ground pad and the black one on my V out, I won't damage the circuit or break anything, but I'll get a negative value. See how it says -5? That is telling me that I've got the polarity reversed. So it's still giving me an accurate reading of the voltage, but I have it backwards. Okay, let's move on. I'm going to put this away because we're done with that. And look at ohms. So move that over to the ohm dial, and this is where we can measure resistance. It measures resistance by putting a very small voltage across the probes. And as you see it, when I touch those, it's actually measuring the voltage across me. So like I can measure the voltage, the resistance of my skin somewhere, and it will give me a value, like it's giving me around 200, 220, and then it says K ohms. So that's 1,000. So it's like 320,000 ohms. That's pretty high resistance, right? So like my skin is conductive, but it's not very conductive the way like wire is. If I can touch these probes together, I'll get a very low reading, 0.6 ohms, right? Not even 1 full ohm. So these are very conductive, but they don't have zero resistance, right? So it still takes effort for the electricity to get through these cables and then back out the other one, and that's measured as that like 0.6 ohm resistance. So the other thing we can do with these, we can measure resistance of any material. You know, I just showed you 2, but we can also measure our resistors. So the resistors have codes on them that we can read with the little color codes. Like this one is a red, red, brown, and you can look that up on a chart. The red, red, brown is a 220 ohm resistor, so the red is 2, 2, and then brown is a multiplier to give us 220. And if I measure this, holding it between the probes, 216.8. So that's pretty good. I'm a little off. That could be the resistor itself. The gold is my accuracy of the resistor. I think the gold is 5%. So it should be within 5% of that value if I have a good resistor. Let's measure another one to see a difference here. This one is a red, red, orange, also gold, but that should be like 22,000 ohms, so much higher. And I'll hold this, and it immediately jumps to K ohms again, and we're at 14.8. 5. Slowly going up, and this is where we might begin to see something like the disadvantage of the auto ranging is that it's taking some time to settle in on a reading that it wants for this resistor. You see I'm holding it, you know, with my bare hands here. The voltage is so low from the probes, I can't even feel it, right? It's not going to hurt me or harm me in any way using the multimeter for ohms readings on a circuit that's not live. All right, let's look at a diode. So we can measure a light emitting diode like an LED or a regular diode. With these ones, the polarity does matter. So I'm going to put my shorter leg on the ground and the red on the long positive lead. And that's going to, so you see the units goes to volts. So it's telling me how much volts are going across the LED, 1.8. Small quantity of volts. And the LED is actually lighting up. You might not be able to see that in the camera video. Barely. You can see a little bit of that light up there. But that's a way I can check to see if I still have a good LED or if I've burnt it out somewhere along the way. If I do this one backwards, you see it gives me OL, overload, in its default state, and it's going to continue doing that if I do this one backwards. So if I try this, either my LED is dead or I've got it backwards, so I want to try switching it to make sure. Okay. Our next reading is capacitance, or I'm sorry, continuity. Continuity is one of the ones you'll use the most, and this tells you if two things are connected in a circuit, and it makes a beep. And that's really helpful because you can be looking at a circuit somewhere else. You don't have to see the screen here. You just hear that beep and you know they're connected. So if I touch these together, I get a beep. And it will show me actually the resistance, right? So I'm back to my 0.5 ohm resistance between the two probes. This is great for detecting if a material is conductive. For instance, I've got this binder clip, right? And I want to see, does this side connect to this side in terms of conductance? I mean, the whole thing's metal, but this black part's like painted. Does it go through that? Yes, it does. Great. So I know that's conductive. So I can test things that are conductive. I can also test a circuit. So I've got a little circuit here. I've got two ground pins on my header there. I'm going to just wedge this probe there, and then I can check points on my circuit to see, are those connected to ground. So if I'm making a circuit and I know, for instance, that these should be connected, and I test this with my probe and I don't get the beep, that means my solder job is bad. I've got to check my solder points, right? So this is a great way to check if your solder connections are good across things that should be connected in a circuit. Our last one is capacitance. I can use this to measure a capacitor. This capacitor has a stripe on it, right? A bigger capacitor, this is a 10 UF capacitor, it says that right on there, will have polarity, right? So again, the short leg, the leg with the stripe, is going to be my ground one, and then the positive one goes on the other side. And this is where I've noticed it'll take a seriously long time to land on the value, but at least it's giving us a decent ballpark right off the bat. 15 UF is relatively close to where we want it to be. So that's how we use a multimeter, the auto-ranging multimeter, to measure different aspects of a circuit. Very helpful tool to know how to use in physical computing. Oh, and remember when you're done to turn it off so your batteries don't die.